Okay, so we've come to the topic of naming acids. So take a look at HBr, right? What kind of compound is that? And hopefully when you're looking at that, you're thinking, okay, I would need to classify the type of compound before I name it. So if you're going to do that, H and Br, that's a nonmetal and a nonmetal. So that's molecular. And then you'd be correct. This is a molecular compound. But it also is classified another way, and these are what we call acids. In this class, when you see an acid, it's going to have H in the front and then something over here. This is going to indicate to you that that's an acid. Now, there are, like in organic chemistry, further down the road, there are a lot of acids where we don't put the H in the very front, and we actually put it at the very end. But it takes a lot of sort of learning to sort of get to that point where you recognize that that's what that is. So for most general and chemistry courses, like this is an intro to Gen Chem, we usually put the H in the front. Now, this is a molecular compound. It's an acid as well. And what that means is when you put it in water, it's actually going to break apart and give you H plus, hydrogen ion. Okay. And so it gets as a molecular compound, you would just name it hydrogen bromide. But we have a worksheet that you'll be doing along with this lecture. And it's about naming ionic and covalent compounds and naming acids. In the naming acids ones, you want to name it as an acid. So the way that you do that is if it ends in IDE, right? Binary, IDE becomes ic. So this is hydro. We add hydro to the front. Bromic acid. Like that. Okay. Oh, let me erase that. My computer's slowed way down. It's gotten really hot. Hydro. I can't actually see what I'm writing because it's behind. I'm going to pause and let my computer cool down. Well, I think I'm just going to have to write slower. So it's, that's better. Hydrobromic acid. We always add the word acid to the end. Okay. Now, H2S as a binary would be dihydrogen sulfide. So, to name it as an acid, we just take the sulfide and add hydro and change the suffix to ic, and then add the word acid. So this is hydro. And for sulfur, we add the UR back. So hydrosulfuric acid, like that. And then HI as a molecular compound, right, is hydrogen iodide, but because it ends in IDE, we say hydroiodic acid. So if it ends in IDE, we put a prefix of hydro and we end it with the word, or the suffix ic, and end it with the word acid. Oxyacids, depending on the suffix of the polyatomic ion that's in the compound, right? How to say this? We change what suffix we use. So for example, if it ends in ITE or ATE, so you'll recognize like it has an oxygen in it as a polyatomic ion because it always ends in ite or ate. Hydro is always, or IDE is always either monatomic and a few polyatomics, okay? So we're going to change ite to us and ate to ic. And a saying that people tend to remember is the white mouse ate icky cheese. So ate goes to ic, right? And sorry, some of the white mouse ate. oh, sorry, I goes to us, and 8 goes, I was like, where'd the rest of the saying go? I goes to us, and 8 goes to ick. So if it ends in ite, you go to ous, and vice versa if you're trying to go the other way, right? If it ends in ate, you go to ic. Not that, don't leave the k out of there. Oh, that's supposed to say icky. All right. So H2CO3, that would be hydrogen carbonate. That would be its molecular name. We would name with the hydrogen, and then we would say carbonate. In fact, there's 2 hydrogens, so it would have to be dihydrogen carbonate. Now, when we name it as an acid, we ignore the hydrogen, and we look at the polyatomic ion. And so what we'll write is, right, carbonic, so carbonate is what the anion is. We'll name it as carbonic acid, like that. Now, this is one of those polyatomic ions that you just have to remember, and it's known as acetate. And the compound as a molecular compound would just be hydrogen acetate, because there's just the one hydrogen on it. So in naming it as an acid, because it ends in an ate, we would call it acetic, or acetic is actually how it's pronounced, acid. And this is the acid that we have in vinegar. It's about a 5% acetic acid solution, and that's what makes vinegar. It's also what makes vinegar sour. Most of the acids are sour. So the next one's a little trickier, only because we haven't seen it very much. So what I'm going to do is figure out what the anion is, and I always tell people, like, cover up the first, right? Now, ClO, wait, what is that? So the process that should go through your head is, what is ClO3? What is chlorate, right? Is what should be going, because you use ClO is related to chlorate. So you want to say, what is chlorate? And chlorate would be based on the position in the periodic table. We'll do this again. It's here. So it's going to have 3 oxygens and a -1 charge, right? So now what I'm going to do is I'm going to say, well, this is chlorate, ClO3 minus, so chlorite would be ClO2 minus. So ClO minus is hypochlorite. Oh, ite. And this would be hydrogen hypochlorite if it's named as a molecular compound. But as an acid, which is normally what we're doing, because it ends in ite, we're going to use ous as the suffix. And so it becomes hypo, we don't lose that part, not hydro, but hypo, chlor, and then the ous ending, ous acid. And, right, the per would still apply to this, because you see IO4, you have to think to yourself, what is iodate, right? Because that's the name that should pop into your head when you see I and O. And iodate is IO3 minus, so this is per iodate. So now it's hydrogen periodate as a molecular compound, but as an acid, what we're going to do is we're going to take and change the 8 into ic, and so this becomes periodic acid. And oddly enough, it looks like periodic acid, unfortunately, but anyways, it's kind of funny. That's why I did it. So this is periodic acid, not periodic acid. All right, cool. Now, last thing we have to do is calculate formula masses, but that's it for the nomenclature. You should be able to do all the homework in the chapter except for this last bit we're about to talk about.